Hi everyone, welcome to the Simplilearn YouTube channel. This session will be about Golang for beginners. Before we begin, let me inform you about the daily updates on multiple technologies on our channel. If you love hunt for technological stuff, consider getting subscribing to our YouTube channel and don't forget to hit the bell icon to never miss an update. We from Simplilearn bring you this beautifully designed, organized and upgraded Golang course for beginners for 2022. Now, let's start with today's agenda and confirm me whether am I audible or not by commenting in the comment section. So first, we will start with the introduction to the Golang programming language. Following, we will learn to install Golang on Windows and to write our first program in Golang. After that, we will start with the basic concepts in Golang. Moving on, we will educate ourselves with Go interface, followed by Go concurrency, and afterwards we will have an introduction to Golang Grpc. With the topics covered till now, we can have a comparison between Golang and Python. Finally, we will be implementing Golang by developing the Go REST API. Go, also known as Golang, is an open source programming language developed by Google. It is a statically typed compiled language. Moreover, Go supports concurrent programming, that is, it allows running multiple processes simultaneously. This is achieved using channels, goroutines, etc. Go language has garbage collection, which does memory management and allows the deferred execution of functions. It also supports networked and multi-core computing. You can run your first code without any setup on the playground provided at golang.org. We will look into the history of Golang. The Go programming language was born due to the complexity of managing the infrastructure and code bases within Google. The language creators, all from Google, had a clear goal: design a programming language that would be easy to use but still be able to cover the main challenges while working with the company's intricate systems. Go was designed by Robert Grismer, Rob Pike, and Ken Thompson, and was designed at Google in 2007 and was announced to the public in 2009, and it was made open source in 2012 with the release of version 1.0. The most remarkable release, that is Golang 1.5, was presented in August 2015, and it included considerable changes. The compiler toolchain has been converted from C to Go entirely, and at this stage, Golang took the form to which its authors aspired. Now, we will be knowing why to learn Golang. First reason, that is easy to use and learn. Golang is easy to use and understand. It has gained popularity in the top 20 programming languages. Go has a linear learning curve that appeals to novice programmers. If someone already has hands-on C# or C++, learning Go for them should be more accessible due to its striking similarities to C. The next point we consider is community and documentation. You can find the documentation on the official website, that is golang.org. Go has solid and easy to read documentation. Apart from documentation, Go also has a supportive and active community. You can use the hashtag Golang whenever got stuck on Twitter to reach out to the community. Impressive standard library. Go users have a standard library packed with the language, which reduces importing complex secondary libraries. Go's standard library is vast but not confusing, that is, without the issue of conflicting function names. One of Go's best contributions to programming is it offers a more straightforward way of integrating data structures into code blocks. Next reason to learn Golang is strong security. Simple code is safe and more secure than complicated code. As Go is a statically typed language, Go users don't have to debug a lot of errors, which is the case with many dynamic languages and their number of variable types. Plus, the inclusion of a garbage collector also helps prevent memory leaks. And the last reason to learn Golang is attractive wages. According to a survey conducted by Stack Overflow, Go developers are the third highest paid after Perl and Scala. Due to Go's increasing popularity every year, this figure will continue to rise. Now, we'll look into the features offered by Golang. First, that is flexible. Because of the language design and its roots from C, Golang is easy to learn and understand with simple syntax. Next, concurrency. Go allows multiple processes to run simultaneously. Its ability to take advantage of multi-core processor architectures and efficient memory is one of the reasons why Go code is today running some of the most heavily used applications that can scale. Next is the fast output. Go comes with a very quick compilation time. In the Golang development environment, there is no virtual machine. The code is directly compiled to machine code, making the compilation process faster and more effective. Besides, the compiler produces only one executable file after compilation. This file does not suffer from dependency and can be uploaded and run anywhere. This makes the code execution process faster. The next is library. Go comes with a powerful standard library distributed as packages, which also reduces importing complex secondary libraries. The next feature is garbage collection. This is Go's one of the key features. It controls memory allocation and has significantly reduced latency in the newer versions. Developers need not worry about freeing up pointers or the situation associated with dangling pointers. Now we'll see the uses of Golang. Go was originally built for programs related to networking and infrastructure, intended to replace popular high performance server side languages like Java and C++. Golang's support for concurrency makes it an excellent choice for handling bottlenecks that prevent scalability. Today, Go is used for a variety of applications. Go is popular for cloud-based or server-side applications. Concurrency and networking features align with its high portability across various platforms make Go an exceptional language for cloud computing. As a matter of fact, many standout cloud platforms like Kubernetes were built with Go. Google Cloud also uses Go to enhance scalability and performance. DevOps and site reliability automation are also popular ways to use Go. Many command line tools are written in Go. Also, Go is used in the world of artificial intelligence and data science. Some uses Go for microcontroller programming, robotics, and games. However, Go shines the most when it comes to infrastructure. Today, some of the most popular infrastructure tools are written in Go, such as Kubernetes, Docker, and Prometheus. Now, we'll see some popular IDEs used by Golang programmers. Golang. Golang is an IDE by JetBrains to provide an ergonomic environment for Go development. Sublime Text. It is a commercial source code editor that supports many programming languages and markup languages. You have to install Go Sublime plugin through package control that provides Go code completion and other IDE-like features. Go Clips. It is an Eclipse extension that adds IDE functionality for the Go programming language. Vim. Vim is often called a programmer's editor. Plugins adds Go language support for Vim. Visual Studio Code. Using the Go extension for Visual Studio Code, you get features like IntelliSense, code navigation, symbol search, testing, debugging, and many more that will help you in Go development. You can install the Go extension from the VS Code marketplace. Now we'll see some companies using Golang. Uber, a ride-hailing platform that uses Go within its microservices. Kubernetes. Kubernetes is an open source container orchestration system used to automate software deployment Scaling and management. Google designed Kubernetes, but the Cloud Native Computing Foundation currently maintains it. Dropbox. Dropbox is a file hosting service that has migrated some major components from Python to Go. Netflix. Netflix is the most popular OTT platform and has used Go to develop its server architecture. Twitch. Twitch is a live video streaming platform that uses Go for many busiest systems. SoundCloud. It uses Go to perform static analysis in real time, which is possible due to static typing and fast compilation. In this session, we will go through a brief introduction to the Golang language. After knowing the basics, you will get to know about variables, data types, and operators in the language. Further, you will learn about loops supported by the Golang, and you will know how to declare the functions and pointers in Golang. Finally, you will learn about the packages. We will look into what is Golang. Go is a strong and statically typed compiled language. Strong language depicts that the type of variable cannot change in a code. It will remain the same throughout the code. Here, statically typed means all the variables must be declared at compile time. And compiled language states that you only have to compile the code and it will be converted to machine code directly. It is same as C or C++. Go doesn't have a virtual machine like Java language, which takes time to convert the script into machine code. Moreover, Go supports concurrent programming, that is, it allows running multiple processes simultaneously. This is achieved using channels, goroutines, etc. These features help Go to improve its performance. Companies such as Google, Twitch, and Uber use Go for their microservices. Technologies like Docker, Kubernetes are developed in the Go language. We'll go to the official website of Go. For that, we'll move to Google Chrome and search for Golang. This is the official website for Go, that is go.dev. Here we can see the mascot of Go language. This is the blue mascot. As we scroll down, we can see the companies using Go language. Go is called the minimalistic language as it has very little documentation. It is easy to learn as it has fewer features and less confusing parts as compared to Java. Here, you can run your first code without any setup on the playground. We will run hello world here. We will write hello world and click on the run button. It will send the code to the server for compilation and we will get the output, that is hello world. We can download the Golang from here. We will click on the download button and here we can see we have download options for Microsoft Windows, Apple Mac OS, Linux, and we have the source file. I have downloaded for the Windows as I have the Windows system. Apart from downloading Go, we also have to download an IDE to run the code. For that, I have downloaded and installed VS Code. It's up to you what IDE you want to choose. Now, we will learn about variables in Golang. A variable is a storage area defined to store temporary data and perform operations on them. Moreover, variable values can further be changed according to program needs. Variables declared without any corresponding value are considered zero-valued. There are mainly two ways to declare variables in Golang, that is using var keyword and using short variable declaration. Let's move to VS Code and see the declarations live. Now we will open a new file and see how to declare variables in Golang. And we'll use the inbuilt terminal of VS Code. Here we will select the language as Go and press enter. The first thing we will do is import fmt. For that we'll write import and in inverted comma we'll write fmt. That is a formatting package. and it contains the print function. Everything in Golang is inside packages, whether it is a print function or any other function. We use packages by using import and writing the package name in inverted commas, that is import inverted commas fmt. If someone wants to use your script, he can by importing your Go file or your Go package. So it becomes mandatory in Golang to put the code in a package. Here we will put our code under the package main. So we will write package main. We will declare a main function in which we will write our code. We will write func and the name of the function as main, round brackets, and we'll start the curly braces, and inside these curly braces we will write our code. We will declare a variable. To declare a variable, first we need to write the name of the variable, second type of the variable, and then the data assigned to the variable. For that we will write var keyword, name of the variable we will keep it as a, and then the type of the variable, that would be int, and we will assign the value 7. We will declare another variable, that is b, var keyword, name of the variable as b, and the data type int, and we will assign the value 96. Now we want to print these variables. For that we have imported the fmt package. For that we will write the command fmt dot println a comma b, and for that first we will save the file. We will name the file as demo.go, and now we will run the command in the terminal go run demo.go and press enter. Here we can see the output, that is 7 and 96. That is, we have successfully printed both the variables, that is a and b. We can also declare the variables in different form, like we can write variable keyword, and if we want to declare two variables we can declare them in the same line. For that we will write variable t comma e and the data type, that would be int, and in the next line we will assign the values to them. D comma e equal to 7 comma 21. Now we will print these variables. For that we'll write the command we'll save the file and run the same command in the terminal, that is go run demo.go, and press enter. We can see the output, that is 796 and 721. Now we'll see another method, that is short variable declaration method. For that we'll just write the name of the variable, that is v colon equal to, and the value that we want to assign to this variable. We will assign 76. It is same as the previous method, that is variable, the name of the variable, data type, and the assigned value. Now we'll also get this variable printed. For that we'll write the command fmt dot println, in circular brackets we'll write the name of the variable. We will save the file and run the same command in the terminal, that is go run demo.go. We will traverse to the next topic, that is data types in Golang. Data types specify the type and space allotted to variables or functions. There are four categories of data types in Golang, that is, bool type. It represents a Boolean value and is either true or false. The next is numeric type. It represents integer types, floating point values, and complex types. The next is string. It represents a string value. And we have the derived types. It includes pointer types, array types, structure types, and many more. See some demonstrations in the VS Code. First, we will see the float type. We have seen the integer type in the previous example of variables. Now we will add two float numbers and print the output. For that, first we will declare the float number, that would be 96.28, and we will declare another variable, that is float variable, and assign a value that would be 18.09. Now we will declare another variable as the output variable, and we'll store both the variables by adding them. Now we'll print the C variable, that is the output variable. We'll save the file and run the command in the terminal, that is go. We can see the output, that is 114.37. It shows that both the float values have been added. Now we'll see another data type, that would be string. First we'll clear all the code that we have written. Now we will declare a string variable str colon equal to, and we will write Simplilearn as a string, and we'll print the string fmt dot println str. Now we'll save the file and run the command in the terminal, that is go. Here we can see that the Simplilearn string has been printed. Now we will move to the Boolean data types. For that we will use the same code only, and we will declare another string, that would be string1, and we will store string learn in it. And now we will compare both the strings. We'll declare another variable, that is out, and in this we will compare both the strings, and we will print the variable out. We will save the file and run the same command, that is go in the terminal. Here we can find that the output is false because the string str, it contains the string Simplilearn, and the string str1, it contains the string learn. So we are comparing both the strings and they do not fall same, so it gives the output as false. Now we will traverse to the next topic, that is operators in Golang. An operator is a specified operation that is performed on the operands. The following list describe the different operators used in Golang. First is arithmetic operators. It includes addition, subtraction, multiplication, division, and modulus. Let's see some example in the VS Code. First, we will erase all the previous code, and we will declare two variables to perform operations on them. We will declare variable a and assign the value 96 to it, and another variable, declare another variable that is b colon equal to that is 18, and now we will perform different operations on them. First we will perform addition. We will declare another variable that is out, and we will store both the variables by adding them, and print the out variable. We will save the file. Here we got the output as 114, that is addition of both the variables. We will perform next operation, that is subtraction. For that we will declare another variable that is out1 and perform the operation as a minus b, and we'll print the variable out1. We'll save the file and run the same command, go run demo.go. Here we can see the output as 78, that is 96 minus 18. Now we'll perform another operation, that is multiplication on both the variables. For that we'll declare another variable that is out2 and print the variable out2. We'll save the file and run the same command in the terminal, and we have find out that the output we got is 1728, that is the multiplication of both the numbers 96 and 18. Now we'll perform another operation, that is division, and for that we will declare another variable that is out3, and we'll perform a divide by b, and we'll print the variable fmt dot println. The variable is out3. We'll save the file and the same command in the terminal, and we would find 5, that is the output of the variable out3. That is, we have divided 96 by 18. Now we'll see the last operation in the arithmetic operators, that is modulus operator. For that we'll declare another variable that is out4, and we'll perform the operation a modulus b, and we'll print the variable out4. We'll save the file and run the command in the terminal. We got our output as 6. Now we'll see some relational operators, that would be equal to, not equal to, greater than, less than, greater than equal to, or less than equal to. For that, first we will clear the variable out and we'll perform another operation, that would be a is it equal to b. We'll save the file and run the command go run demo.go. What we find is false, because both the variables have been assigned different values, that is 96 and 18, so they are not equal. We'll perform another operation, that would be a not equal to b. We'll save the file and run the command in the terminal. Here we got true as the output, because both the variables have been assigned different values and they are not equal. We will perform another operation, that is less than. For that we'll clear the previous operation and we will write the operation whether a is less than b or not. We'll save the file and run the same command go run demo.go. We have come across the output as false as the operation is a less than b, but a holds the value 96 which is greater than b, so it gives the output as false. Now we will move to logical operators. Logical operators consist of logical AND, logical OR, and logical NOT. We will see the example of logical AND. For that, we will write the statement if A is not equal to B, logical AND A is greater than equal to B, and if the statement is true, we would print out fmt.println yes. We'll save the file, run the command in the terminal. Here you can see that we got the output as yes. It means that A is not equal to B, that is 96 is not equal to 18, and 96 is greater than equal to 18. So this is the logical AND operator. Now we will see bitwise operators. Bitwise operators consist of bitwise AND, bitwise OR, bitwise OR, left shift, right shift, and NOT. We will see an example of bitwise AND. For that, we will declare a variable that would be ARR O, and we will perform bitwise AND on A and B, and we will print the result, that is ARRO variable. We'll save the file and run the command go run demo.go. Here we have find out that it gives the output as 0. So what does bitwise AND operator do? It takes both the numbers 96 and 18 and perform AND on every bit of both the numbers, and the result of AND is 1 only if both bits are 1. Now we'll move to another operator, that is assignment operator. It consists of various operations, that is single assignment, add assignment, subtract assignment, multiply assignment, division assignment, modulus assignment, bitwise AND assignment, bitwise exclusive OR, bitwise inclusive OR. We will see an example of simple assignment. For that, we will just write the statement a simple assignment that is equal to b and print the variable a. We'll save the file and run the command in the terminal. Here we can see that the value of the variable a has changed and it has turned out to be 18 because we have used the simple assignment operator. Now we will traverse to the next topic, that is loops in Golang. A loop is the repetition of a block of code that executes a control statement specific number of times. Go language works with a single loop, that is for loop. And moreover, Go language uses for loop in various forms, such as infinite loops, for loop as while loop, and using for loops for strings and maps. We will see a simple example to print Simplilearn string 7 times. For that, we'll move to VS Code and clear all the previous data and start with the for loop for and initializing the variable I, that is I equal to 0, semicolon, I less than 7, I plus plus, curly braces, and now we'll write the statement to print Simplilearn. Now we'll save this code and run the command the terminal, go run demo.go. Here we can see that we have printed Simplilearn 7 times. We will traverse to the next topic, that is function in Golang. A function is defined to execute tasks by writing blocks of code. It reduces the excessive use of memory with the reuse of the code. In Golang, we declare a function by func keyword followed by the name of the function with parentheses and then a block containing the code. Now we'll see the syntax of the function. First, we'll write the func keyword, then we'll write the function name and the parameters for the function. After that, we'll write the return type, and in curly braces, we'll write the function body. Golang also contains a special feature, that is anonymous function. We will see a simple example of multiplication function that would be defined by us, and it would get two arguments in that. For that, we'll move to VS Code and we'll erase this for loop. Now we'll declare a multiplication function outside the main function. Here, first we'll write the func keyword, then the name of the function, that we will write multi, and then we'll pass the arguments t, e and assign their data type and the return type of the function, and then we'll start with the curly braces, and here we will declare a variable that would be out, and it will perform the operation of multiplication, and we will return the variable out, and inside the main function we will declare two variables, a equal to 76 and b equal to 91, and now we'll declare another variable that would be d, and in d we would call the function that is multi and pass both a and b as arguments into it and print the variable d. We will save the file and run the command go run demo.go. We have got the output as 6916 as the multiplication of 76 and 91. Now we'll move to the next topic, that is pointers in Golang. Pointers are considered as special variables in Golang. Pointers are used to store the memory address of another variable. The memory address is stored in a hexadecimal format starting with 0x, like 0x, FF, AA, F, etc. Now we'll see an example of pointers in Golang. For that, we'll move to VS Code and clear out the previous code. Now we'll declare a variable value and assign value 96 to it, and now we will declare another variable, mainly a pointer variable, and now in this variable we will store the address of variable value. Now we will print the value that is stored in the variable value, and the next we would be displaying is the address of value, that is ampersand of value. And now we will display the value stored in variable a. Now we will save the program and run the command go run demo.go in the terminal. Here we have got the output value equal to 96, that is we have printed the value stored in the variable value, and the next we have displayed is the address of the variable value, that is ampersand value, and we have stored the address in variable a also, and that's also been displayed in the next step. So now we would traverse to the next topic, that is packages in Golang. As we have already discussed packages in the beginning, now we'll overview about it a bit. Packages are a directory containing various methods, functions, and large number of programs related to particular functionality. It makes these large programs easy to maintain and understand and help in distinguishing them of the other package programs. To import package in a Go program, we can use import path, as we have seen in the examples we have done so far. In this session, we will learn what an interface is and how to create an interface. After this, you will learn about empty interface. Further, you will get to know about type assertion and type switch. Let's start with what is an interface. The key principle of an interface in Go is to provide method signatures for similar types of objects. Go does not have classes and inheritance to implement object orientation. Go has the interface and abstract type to fulfill this purpose. For example, motor vehicle can be an interface with method signature mileage. Any type which provides definition for mileage method is said to implement the motor vehicle interface. Let's learn how to create an interface. In Go, you can create an interface using the type keyword followed by the name of the interface and the keyword interface. And you can specify method signatures inside curly braces. You will get to understand the creation of interfaces with example. Let's move to Visual Studio Code and create an interface. I have opened a file and named it interface.go. Here we will just create the interface. For that, we will first type the keyword type, then the interface name. We will name it as motor vehicle and then type the keyword interface. We will start the curly braces and inside we can define method signatures. We will define mileage as a method and it would be of return type float, and we will declare another method that would be average speed and that would be of type string. Now we will see how to implement an interface in Go. To implement an interface in Go, you need to implement all the methods declared in the interface. Go interfaces are implemented implicitly. Unlike Java, you don't need to explicitly specify using the implements keyword. In the previous program, we have defined the motor vehicle interface, which has two methods, mileage and average speed, that return float64 value. Any type that implements these methods will also implement the motor vehicle interface. Now, let's look at a practical use of the interface. We will write a simple program in the Visual Studio Code that would calculate the total mileage for a person based on the individual mileage of his cars. For brevity, we have assumed that distance covered is in kilometer and fuel used will be in liters. So let's move to Visual Studio Code and start writing the program. First, we'll write package main, then we will import fmt And now we will declare our interface that would be type, the name of the interface that is motor vehicle, and the keyword interface. We'll start the curly braces and declare our first method that would be mileage, and it has a return type float 64. We have two cars owned by the person BMW and Audi defined by struct ins. So first we will define the struct for the car BMW and Audi. For that we will write type BMW and it is struct type. Inside the curly braces we will define distance that would be of type float 64 and that is average speed and that would be of the type string. Now we have declared the let's declare another struct type that is OD. For that we will write type OD struct and inside the curly braces we will define distance as the return type float 64 and the fuel consumed with the same type float 64. Now to implement the motor vehicle interface we need that the BMW struct and the OD struct should implement the method mileage. For that we will define the method mileage for both of them. First we will declare the method mileage for BMW. For that we'll write function BMW that would return the type as float 64 and we have to declare the method that is mileage and inside the curly braces we will define this function that would return b dot distance divided by b dot fuel consumed. So we have declared the method mileage for BMW. Now we will declare for the type OD struct. For that we'll write function OD method name that is mileage and it would also return float 64. So this would be small and inside the curly braces it would also return the distance traveled by the OD that would be a dot distance divided by the fuel consumed by OD. Now we will also define a function that would calculate total mileage, like both the mileages of BMW and OD in a month. For that we will declare a method total mileage. For that we will write func total mileage and the total mileage function will take a slice of motor vehicle interface as a parameter. So for that inside the circle brackets we will pass a struct of the interface motor vehicle and inside the curly braces first we will define a variable in which we will store the total mileage. For that we will declare tm as the variable and its initial value would be 0.0 as it would return the type float 64. Now we'll run our loop and pass a slice that contains both BMW and OD types to the total mileage function. The total mileage function will calculate the total mileage in the variable tm by calling the mileage method of both the corresponding types. So we will define range m and inside the curly braces we will add up the mileage and we will get it print out that would be fmt dot print f total mileage per month, that is of float type, and it is in kilometer per liter, and it is stored in the value tm. Now we will define the function main. So first we will assign the values for the struct type BMW. For that we will assign the values in the variable b1. Distance would be 167.9 kilometers covered, comma. Fuel consumed would be 36 liters, comma. And the average speed for BMW would be 58, and we have declared the average speed as the type string, so we will make 58 in the inverted commas. Now we will declare a variable a1 for the type OD and store the values for the type struct OD. Distance covered would be 152.9 kilometers, and the fuel consumption would be 30 liters. I forgot to put the comma here. Yeah. So now we will declare a person variable who possesses both the cars, and he wants to calculate the mileage of both the cars in a month. So here we will pass the slice motor vehicle, and inside the curly braces we will pass both the variables p1 and a1 and call the method total mileage and pass the person variable in it. We'll save the code and run the code in the terminal. For that we'll open the new terminal and write the command go run and the file name, that is interface.go. Press enter. Here we can find the output, that is total mileage per month is 9.760556 km per liter. Now we have learned how to implement the Go interface. Let's move to another branch, that is empty interface. When an interface has zero methods, it is called an empty interface. This is represented by interface and the curly braces. Since the empty interface has zero methods, all types implement this interface implicitly. Better understanding, we will understand the empty interface with the help of an example. We will move to Visual Studio Code and create another file and name it as empty interface.go. And in this file, we would see an example how to implement an empty interface. For that, we'll write package main and import the package fmt. Now we will declare a variable I for the interface and just make the curly braces. Now we will declare a function found and pass the interface, and inside the curly braces we will find the type and the value of different types which would be implementing the empty interface. For that we'll write fmt dot printf the type equal to %t, comma, and the value of the type %v/n In function main, we would declare the types which would implement the interface, that is an empty interface. For that, we will write function main starting with the curly braces, and first we will declare a variable s, and inside we will store a string that would be Simplilearn, and call the method found, and we'll pass the variable s in it. Now we will run this code. For that, first we'll save the file, that is Control S, and now we'll run the command go run empty interface.go, press enter. Here we can see that the output is type equal to string and the value stored in it is Simplilearn. Instead, the string type has implemented the empty interface. Now we can declare more types that can implement the empty interface. We will declare a variable that would be I, and it would store an integer value that would be 7, and we'll pass this variable into the method found. Now we'll save the program and run the file again. Here we can find that the type equal to int and the value stored as the int type is 7. So it's clear that as many types can implement the empty interface. We'll move to the next topic, that is type assertion. Type assertion. You can find the dynamic value of an interface using the syntax I.type, where I is a variable of type interface and type is a type that implements the interface. Understand the type assertion with the help of an example. For that, we'll move to the Visual Studio Code and see the interface.go file. Here we have the average speed declared in the struct BMW. We will declare a method that would be average speed. For that, we'll write function BMW, the method name that would be average speed, and it has the return type string that would come in front of the function name, and inside the curly braces we will define the function. It would return the value average speed. Now if we want to get the average speed of BMW printed, we won't be able to do that. We can see in the total mileage function we would print fmt.printf m.average speed. As the interface motor vehicle, it has only a single method, that is mileage. It can't access the average speed of the struct type BMW, so it won't be able to print the average speed. This is where type assertion comes into play. Type assertion lets us extract the value of the underlying type, that is BMW here, and then it will call the methods on the return value, that is M. In order to do that, we have to make a type assertion of the underlying type, that is BMW, of that interface. Once we are able to do this, we can extract the value and store it in a variable, and then we can call the methods on that variable, because now that variable has type and value equal to underlying type and value of the interface. For that, first we will copy this code and create a new file, type assertion.go, and paste the code in the new file. Now we will clear the function total mileage and declare a variable AU. We will extract out the value in the variable AU only. For that we will write m dot, and in the parenthesis we will write BMW. Here m is the variable at which we are making an assertion about. It would be followed by the period, and in parenthesis we will place the underlying type of that interface. The Go program does not see this parameter as BMW, it sees it as a motor vehicle interface. Now the underlying value has been extracted in the variable AU. We can call all of the methods of BMW by simply putting in the println function. First we will declare the println function. For that, we'll write fmt.printf and we will call the average method, that is au.average speed. And now we will pass the BMW struct that would be declared in the variable b1. So we will erase this and we don't need the slice here, and in total mileage we would be passing the b1 variable. We will save the file and run in the terminal. Here we got 58 as the output, that is we have passed average speed as a string and that has the value 58. Now we have understood the implementation of type assertion. We will move to learn the next topic, that is type switch. In type switch, you get the dynamic type of the interface instead of the dynamic value with syntax like type assertion, that is I.type, where I is a variable of type interface and type is a type that implements the interface. Type switch is similar to creating multiple else if statements in code. We would understand this with the help of an example. For that, we will create a new file that would be type switch.go. In this type switch example, we would define an empty interface and we would declare different types that would be implementing this empty interface with the help of type switch. For that, we will write package main. We will import the fmt package. We will declare a function named like. We will write function like and pass the empty interface with the variable I. Now we will write switch I.type in the curly braces and it specifies a type switch. Switch I dot in the parenthesis type, and now we will define different case statements and compare the concrete type of I to a specific type. If any case matches, the corresponding statement will be printed. First, we will define a case that would have string as a type, and if the value matches with the type string, it would print the statement I learn at %s. For the next line, we would write /n and the variable I dot string type. We will pass different types in the function like in the function main. If any case matches, the corresponding statement would be printed. The next case would be it will have the integer type and it would print, so P would be capital. Okay, fmt period printf, and in the circle brackets we would write about the age. I am %d years old. For the next line we have inserted /n and we'll pass the variable I dot int. Now if the value doesn't matches with these cases, we would define a default print statement that would be fmt.printf. In the circle brackets we would write unknown type. Now we will come to the function main. In the function like, first we'll pass a string value that would be Simplilearn, and we'll call the like function again and pass an integer value, and we will pass an float value that would be 12.89. Now 12.89. Now we'll save the code. It's showing an error. Okay, we didn't define the curly braces here. Okay, the P is small of printf. Okay, now we'll save the file and run in the terminal. Go run type switch.go. In the output, we can see that we have printed the statement I learn at Simplilearn and I am 27-year-olds and the unknown type. So we have first passed the value that is Simplilearn. It matches with the value string and it printed the statement I learn at Simplilearn. The next value we passed is int type and it matches with the case int and it printed I am 27-year-old. And next we have passed a float value and we didn't have any case for the float value, so it printed the unknown type. Now we are clear with the type switch. In this session we will learn about what concurrency is and how parallelism is different from concurrency. After this you will learn about concurrency in Go. You will get to know Go supports concurrency with goroutines and channels. Here we will take a dig at knowing goroutines and their properties. Further, we will learn about channels. Let's start with what is concurrency. Concurrency is a process that deals with loads of activities operating simultaneously. Let's understand the concept with the help of an example. Let's consider a person driving a car. While driving, he feels hungry and reaches a drive-through and collects a food parcel. He holds his car into a parking lot, eats the food, and heads to his home. Here, the person is capable of performing both the actions simultaneously, that is, having his food while driving, but he performs actions in a sequence. This is concurrency. Moving on, we will understand how parallelism is different from concurrency. Both parallelism and concurrency produce the same result, but with different approaches. Parallelism is the process to perform various actions simultaneously, particularly not in sequential order. Let's understand parallelism with the help of an example discussed during concurrency. Let's assume the person is driving the car and simultaneously eating the food. In this scenario, the person performs both actions simultaneously, that is, parallelly. This is parallelism. Parallelism doesn't always result in faster execution time. In parallelism, actions are performed parallelly in multiple cores, creating the need for components to communicate with each other, where concurrent systems have a low communication overhead. Now, understanding the differences, we will head to understand concurrency in Go. Popular programming languages like Python and Java use thread pools to execute concurrency, whereas Go has built-in features, goroutines and channels to achieve concurrency. Goroutines are much easier to manage than thread pools that are purely operated by the operating system. Go works on the communicating sequential processes CSP concurrency model. Now, we will understand how goroutines and channels operate in concurrency model. First, we'll head with goroutines. A goroutine is a function that executes concurrently with other functions or goroutines. Goroutines work in the background while the main part of your program goes on to do something else. Goroutines are not OS threads. To work with goroutine, you have to prefix the Go keyword to the function or method. A goroutine is a lightweight thread managed by the Go runtime. Now, we'll understand the usage of goroutine with the help of an example. First, we will go through the properties of goroutines. Every program consists of at least one goroutine, and that goroutine is known as the main goroutine. Goroutines are deeply integrated with Go's runtime. Go's runtime monitors goroutine behavior, suspends them when they become blocked, and then presumes as they are unblocked. Goroutines are inexpensive compared to threads. They possess only a few KB in stack size, and the stack can expand and contract according to the application, whereas the stack size is fixed in the case of threads. Now, we'll understand the goroutines with the help of an example. Here, in this example, we would be passing 11 and 77 as a string to the function number and then printing it with the loop 7 times. So here inside the package main we will declare a function number and pass a string to it. Inside the function number, we'll run a loop 7 times and print the pass string. To print, we have imported fmt package. Now, in the function main, we will call number function and pass 11 and 77 as string. We will save the file. Here, I have saved the file with the name concurrency.go, and we will open the terminal and run the file with the command go run and then the file name. We have to make sure to perform this operation in the same directory where the Go file is saved. Here, we will write the command go run and then the file name, that is concurrency.go, and press enter. We can see that we got the output as 11 and 77 7 times each. In the main function, first the control will be shifted to the number function where we pass 11. It will get executed and then the control will come back to the main function, and then the control will be shifted to the function number when we pass 77 to it. It will get executed and print 77 7 times. Now the control will be shifted to the main function and the program terminates as there are no other lines of code to execute in main function. Now we will be implementing goroutine. For that we will use the prefix go before the function number. We will write the go keyword before the function number. We will pass the string 11 and we will save the file and run the command in the terminal go run concurrency.go and press enter. Here we can see only 77 as the output would get printed 7 times. We have released a thread go but never waited for it to come back. That's why we have only got it the output as 77. To get the go thread executed, we'll use the sleep method in our program. For that, we will write time dot sleep and inside the circle brackets we will mention the time for 1 second. For that we have to import the package time Now we will save the file and run it. Here we have used the sleep method in our program through time package that will help the main go routine sleep for 1 second, and in between 1 second the new go routine executes, displays 11 as output and then terminates. After 1 second the main go routine reschedules and performs its operation. We can see the output 11 77 11 77 77 11 77 and goes on. Now we are done with the example. Let's move to channels. Goroutines communicate with other elements through channels. Channels can be thought of as a passage through which goroutines communicate. The channel is defined using the make function and the chain keyword. Each channel has a specified type defined with it. This type of data is only allowed to be transported by the channel. The zero value of a channel is nil, and they are not of any use until defined. Channels are designed to prevent race conditions when accessing shared memory using goroutines. In this session, you will learn about what gRPC is, Next, you will learn about the gRPC basic concepts. You will get to know when the gRPC is used, and further, you will learn about the strengths and weaknesses of gRPC. And moreover, we will learn about the companies using gRPC. Let's start with what gRPC is. gRPC is an open source framework that handles RPC, that is, remote procedure calls, and helps build scalable and fast APIs. It allows the client and server applications to communicate transparently and help developers develop corrected systems. This framework works on HTTP/2 protocol buffers and other modern technology stacks to ensure maximum API security, performance, and scalability. Next, we will learn about the gRPC basic concepts, that is, protocol buffers, streaming, HTTP/2, and channels. Let's understand these concepts in elaboration. First one, we'll start with protocol buffers. Protocol buffers or protobuf is Google's serialization or deserialization protocol. It is used as interface definition language (IDL) and serialization toolset by gRPC. Both the client and server should have the latest and same protofile. gRPC stores your data and function contracts in the form of protofiles. Proto-C, that is the protobuf compiler, generates client and server code using the .protofile. It loads the code using the .protofile into the memory at runtime and uses the in-memory schema to serialize or deserialize the binary message. You can exchange the data faster with protobuf as it requires fewer CPU resources since data is converted into a binary format and encoded messages are smaller in size. The next concept we have is streaming. Streaming is another key concept of gRPC, where many processes can take place in a single request. The multiplexing capability, that is sending multiple responses or receiving multiple requests together or a single TCP connection of HTTP/2 makes it possible. Now we'll see through the types of streaming. The first one is server streaming RPCs. The client sends a single request to the server and receives back a stream of data sequences, that is server streaming RPCs. The next is client streaming RPCs. The client sends a stream of data of sequences to the server, which then processes and returns a single response to the client, that is client streaming RPCs. The next we have is bidirectional streaming RPCs. It is two-way streaming, where both client and server send a sequence of messages to each other without waiting for a response. Now we will move to another concept, that is HTTP/2. It is another key concept of gRPC. In a traditional HTTP protocol, sending multiple requests or getting multiple responses together in a single connection was impossible. A new connection will need to be created for each of them. This kind of request or response multiplexing is made possible in HTTP/2 by introducing a new layer called binary framing. And bidirectional streaming was possible full-fledged with the introduction of HTTP/2. The next concept we will move on is channels. Channels are another key concept. The HTTP/2 streams allow many simultaneous streams on one connection. Channels extend this concept by supporting multiple streams or multiple concurrent connections. They provide a way to connect to the gRPC server on a specified address and port and are used in creating a client stub. Now we will understand the gRPC architecture. In the following gRPC architecture diagram, we have the gRPC client and server sides. In gRPC, every client server has a gRPC stub. The gRPC client makes the local procedure call to the stub with parameters that to be sent to the server. The client stub then serializes the parameters with a marshalling process using protobuf and forwards the request to the local client time library in the local machine. The OS makes a call to the remote server machine via HTTP/2 protocol. The server's OS receives the packets and calls the server stub procedure. which decodes the received parameters and executes the respective procedure invocation using protobuf. The server stub then sends back the encoded response to the client transport layer. The client stub gets back the result message and unpacks the return parameters, and the execution returns to the caller. Moving on, we will learn when to use grpc. grpc is used in real-time communication services where you deal with streaming calls, and it's used when efficient communication is a goal, and it's used in multi-language environments, and moreover it is used in internal APIs where you don't have to force technology choices on clients, and it's also used in new builds as part of transforming the existing RPC API. Let's see Grpc Strengths, which has increased the adoption on the old RPC design methods. The first one is performance. By different evaluations, grpc differs up to 10 times faster performance and API security than REST plus JSON communication, as it uses protobuf and HTTP/2. Additionally, protobuf serializes the message on the server and client sides, resulting in small and compact message payloads. HTTP/2 scales up the performance ranking via server push, multiplexing, and header compression. Server push enables HTTP/2 to push content from server to client before requesting, while multiplexing eliminates head-of-the-line blocking. HTTP/2 uses a more advanced compression method to make the messages smaller, resulting in faster loading. The next one we have is built-in community features. grpc provides built-in support for commodity features such as metadata exchange, encryption, authentication, deadline or timeouts, and cancellations. It also provides load balancing, service discovery, and many more. Now we'll see another strength, that is streaming. grpc makes it much simpler to build streaming services or clients. A grpc service supports different streaming combinations through HTTP/2, which we have seen earlier, that is client to server streaming, server to client streaming, or bi-directional streaming. The next is security. The use of HTTP/2 or the TLS, that is end-to-end encryption connection, in grpc ensures API security. grpc encourages the use of SSL or TLS to authenticate and encrypt data exchange between the client and server. Now we have known the strengths of grpc. Now you need to be aware of some points before choosing grpc for developing applications. These points may affect your decision of using grpc. The first one we'll see is limited browser support. As grpc heavily uses HTTP/2, it is impossible to call a grpc service from a web browser directly. No modern browser provides the control needed over web requests to support a grpc client. Therefore, a proxy layer and grpc web are required to perform conversions between HTTP 1.1 and HTTP/2. The next is steeper learning curve. Many teams find grpc challenging to learn. They get familiar with protobuf and look for tools to deal with HTTP/2 friction. It is a common reason why users prefer to rely on REST for as long as possible. The next is non-human readable format. Protobuf compresses grpc messages into a non-human readable format. This compiler needs the messages interface description in the file to deserialize correctly. So developers need additional tools like the grpc command line tool to analyze protobuf payloads on the wire. And they also write manual requests and perform debugging. The next is no edge caching. While HTTP supports mediators for edge caching, grpc calls use the post method, which is a threat to API security. The responses can't be cached through intermediaries. Moreover, the grpc specification doesn't make any provisions and even indicates the wish for cache semantics between server and client. The next is limited community support. The community support for specific technology can be a big consideration for its adoption. With minimal developer support outside of Google and not many tools created for HTTP/2, and protocol buffers, the community lacks information about best practices. This is changing the developers coming in and adopting gRPC. The next we'll see is the companies using gRPC. The first, it is an American multinational technology company that focuses on artificial intelligence, search engine technology, online advertising, cloud computing, computer software, quantum computing, e-commerce, and consumer electronics. The next company that uses gRPC is IBM, that is International Business Machines Corporation. It's an American multinational technology corporation headquartered in New York, with operations in over 171 countries. The next one that uses gRPC is Netflix. It's an American subscription streaming service and production company. It was launched in 1997. It offers a film and television series library through distribution deals as well as its own production, that is known as Netflix Originals. The next company that uses gRPC is Cisco. It's also an American multinational technology and it's located in California. The next one we have is Dropbox. It's a file hosting service operated by the American company Dropbox Incorporation. It's also headquartered in US, that is San Francisco, California. It offers cloud storage, file synchronization, personal cloud and client software. In this session, we will go through a brief introduction to both the languages Golang and Python. After knowing both the languages, we will compare them on various parameters. Further, we will discuss disadvantages of both the languages. Now, we will look into what is Golang. Go, also known as Golang, is an open source programming language developed by Google. Go programming language was born due to the complexity of managing the infrastructure and code bases within Google. Go was designed by Robert Grismer, Rob Pike, and Ken Thompson. It is a statically typed compiled language. Not only that, Go supports concurrent programming, that is, it allows running multiple processes simultaneously. This is achieved using channels, goroutines, etc. And moreover, you can run your first code without any setup on the playground provided at golang.org. Now, let's get an introduction about what is Python. Python. It is a popular, in-demand, general-purpose programming language with straightforward syntax. Python was developed by Guido van Rossum in 1989 and was released in 1991. Python's name was taken from the popular BBC comedy show Monty Python's Flying Circus. Now, we are familiar with both the languages. Let's get down to comparing them. We will compare both the languages on various parameters. Firstly, we will compare on the parameter paradigm. Go is a multi-paradigm programming language. It is procedural, functional, and concurrent language, whereas Python supports four main programming paradigms, that is, imperative, functional, procedural, and object-oriented. Let's compare the two on the topic of performance. When we talk about performance, Go is fast. The performance is similar to that of Java or C++. Go is 40 times faster than Python. To have a check, we will compare the performance of the languages by solving three complex problems, that is, the Mandelbrot equation, n-body problem, and binary tree. It is to evaluate memory usage and time spent to solve the problem. We have chosen these three problems as they are considered the best way to test the memory management and performance of the language. Here, you can see the stats of both the languages. You can see that Golang takes 6.23 seconds and uses 30,108 units of memory, whereas the Python takes 253.19 seconds and 60,410 units of memory to solve the Mandelbrot problem. Binary tree problem, Go takes 29.02 seconds and uses 4,98,160 units of memory, whereas the Python takes 79.03 seconds and uses 4,47,324 units of memory to solve the problem. For n-body problem, Go takes 23.5 seconds and uses 1,641 units of memory, whereas the Python takes 765.34 seconds and uses 7,944 units of memory to solve this problem. This clearly shows that Golang has outperformed Python when it comes to performance. Let's compare the two on the topic of scalability. The whole purpose of developing Golang was scalability. This is why Golang has inbuilt support for concurrent process channeling, that is concurrency. On the other hand, Python has a hard time with concurrency, but it can execute parallelism through threads. Let's understand the concept of concurrency and parallelism. Concurrency means that an application runs more than one task simultaneously, but only one upfront and rest in the background. If the computer possesses one CPU, the application may not progress on multiple tasks simultaneously, but more than one task is processed inside the application. It does not finish one task before it begins the next. You can see the plot of concurrency here. Here, different tasks are running, but only one is running at the upfront and others are running in the background. Now, we move to parallelism. Parallelism means that an application runs its task into smaller tasks that can be processed in parallel, that is, on multiple CPUs simultaneously. Let's see an example of a team of technicians building a monitor. Concurrency allows multiple technicians building different parts of the monitor, but they share one common workbench for assembling the parts. Only one technician can assemble at the workbench at a time, and other technicians operate on their parts in the background. With parallelism, you can have multiple workbenches where technicians can be building parts simultaneously. So, it's obvious that a language has support for concurrency, it is perfect for big and scalable programs. Let's move ahead and compare these two languages based on their applications. Golang is mostly used for systems programming. Due to its inherent support for concurrency, Golang has also found ample use and acceptance in cloud computing and cluster computing. Golang has also seen a lot of recognition and use in artificial intelligence and data science. Due to its powerful and easy to use libraries, Go can set up a web server in a matter of seconds. Go is also used in microcontroller programming, robotics, and games. On the other hand, Python is widely used in web development, data analytics, artificial intelligence, and deep learning. This can be mostly accredited to the insane libraries available in Python that make the life in the said fields a lot easier. Let's compare the two on the topic of execution. Now, let's understand how Go and Python are executed. Golang is a statically typed language, whereas Python is a dynamically typed language. Both Python and Golang use interpreter and a compiler respectively. Now, we will understand what is statically typed language and dynamically typed language. In a statically typed language, variable types are declared explicitly for the compiler so that even trivial bugs are caught easily. Whereas in a dynamically typed language, the interpreter implements type inference. Hence, some bugs may remain because the interpreter interprets something incorrectly. It implies that Python, a dynamically typed language, limits the programmer when he intends to build a really big program. At the same time, Go can handle both types of programs. Let's get on to the libraries in both the languages. In Golang, you would have to write your code to search through data tables. And if you want to implement machine learning, it would be a huge shot to develop in Go. But this doesn't mean Golang falls short in any terms. While developing Go, Google choose the most important libraries as a part of their inbuilt core libraries. We can see here that GOM library, it helps in converting data between incompatible type systems. We can see another library that is CLI. It was developed for building command line apps for Go. GoKit. It is GitHub's popular library for Go related microservices. Authorization Boss. It is an easy way to implement authentication and authorization in your web systems. While the number may not be as boisterous as Python's, the covered usage fields are almost identical. They have built-in libraries for web development, database handling, concurrent programming, and encryption. Yes, Python is almost 16 years older than Go, which results in much larger community and online support. The Python libraries in particular are vast. Exploring data tables can be easily done with pandas, and machine learning is simple with TensorFlow and PyTorch. This type of support can get anyone writing code from the day one. Now, let's get to the next point of comparison, that is readability. While developing software, you will generally work as a team with tens or even hundreds of other developers. At such time, code readability is the major factor to consider. Golang has strict programming rules. It doesn't allow unnecessary variables to be defined or unnecessary libraries to be imported. This implies a definite way to perform a task, leading to a better understanding of code while working in a team. Golang syntax is not friendly to beginners, but it's not as unforgiving as C or C++. On the other hand, Python sure has fantastic readability, but there are probably 10 different ways to say the same thing in Python, which mostly leads to confusion whenever the script is big or while working in a team. Here we can see a simple example of adding two numbers, that is 7 and 9, in both the languages. In Golang, there's a definite way to write a code, whereas in Python, you can write in different forms, but the readability is really fantastic. Now, we will consider memory management as a next comparison. Golang provides with great memory management, whereas Python offers no memory management, which comes in handy while running the complex problems which we have seen above while comparing performances. That's it for this comparison for now. Now we will look into few drawbacks of Go language. Firstly, it is not a generic language. Till now, Go does not have any generic support. This is due to the repetition of codes for the same type of operations but with different data types. Moreover, some data structures cannot be implemented due to lack of generic support. Next is fewer libraries and frameworks. There are no major frameworks for Golang developers. Other languages such as Ruby has Ruby on Rails, Python has Django, and PHP has Laravel. The next drawback is it is still in the development stage. Being in the development stage, Golang developers are finding it hard to make out of its libraries. In case of doubt, there isn't much assistance through the Go community or online support. We have looked upon the drawbacks of Go language. Now, we will look into the drawbacks of Python language. Here, you can see that it is weak in mobile computing, hence, it is not used in app development. The Python uses the underdeveloped and primitive database access layer. You can also see that there's a absence of commercial support for Python. And as Python is dynamic language, it shows more errors at runtime. In this session, you will learn to develop a REST API and then we will perform CRUD operations on it. So first, we will create a folder. We will name the folder as REST API new, REST underscore API underscore new, and inside we'll open the Visual Studio Code. For that, first we'll open the command prompt and write the command code space period and press enter. Make sure the Visual Studio Code has Golang support. For that, you can go to the extensions and search for Go. Install the Go extension. I've already done that. Now, once you have done this Go extension installed, now click on the view and open the command palette and write the command go install slash update tools. It will open all the tools of the Go. You can select them all and click on the OK. So all the Go tools will be installed. Now you can see all the tools have been successfully installed. Now we'll create a new file that would be main.go, and we'll start with writing the package main. We'll run a command go mode init rest underscore API underscore new and press enter. Now we'll run another command. Here it's showing that go.mode file already exists. It has already been created. Now we'll run another command, that is go mode tidy, and press enter. Now we'll create the function main. We'll save the file and now we will import the modules. For that, we'll write the command import round brackets, and inside round brackets we will write the modules, that is encoding slash JSON. The next is net slash HTTP. The next is string conversion strconv, and another we will import would be the Gorilla Mux. For that, we will open the browser and search Gorilla Mux in the web browser. We will open the website, that is Gorilla Mux github.com, and copy the command go get -u github.com/gorilla/mux, and we'll paste the command in the terminal. Press enter, and now we'll import the Gorilla Mux module. For that, we'll write github.com/gorilla/mux. Now in the main function, we'll write the command router. We will initialize it mux dot new router. This function will be executed when we call our goal application. Here we will set up our routers. Here we will create the REST API for employees. For that, we will create a struct with the name profile. For that, we'll write type profile struct, and inside the struct we will hold information for the employee profiles. That would be department. It will be of string type, and in JSON we use the backticks JSON, and it would be represented as department. The next field would be designation. It would also be of the type string, and in JSON it would be represented as designation. And the next field we would get would be employee, and we will make it a complex field. For that we will create another struct that would be type user struct, and inside this struct we would hold the first name, last name, and email of the employee. And in the JSON format we'll use the backticks JSON, first name, and the next field would be last name. It would also be of the type string, and in the JSON format it would be represented as the last name only. The next field would be email. It would also be of the same type string, and in the JSON format we will represent it as email only. Now in the profile struct we will define the employee field as of the type user. That would be of the type user struct, and in the JSON format we will represent it as employee. We will start the web server in the function main. For that we will write the command http dot listen and serve. In the round brackets, first we will pass the localhost port number, and second thing we will pass the mux router. So we will define our port number as 5000. So colon 5000, and the next thing we will pass is the mux router. We'll set up the new routes so that we can operate and perform operations on it. So in the function main only, we'll set a new route. That would be router dot handle function, and inside first we will declare the path, that is profiles, and next the function name. We would name the function as add item, and set the HTTP methods as post. You can see that the handle function has taken the path and the name of the function as parameters. Now we will declare the add item function. This add item function is a route handler and therefore it will take two parameters. First will be response writer, that would be of the type http dot response writer, and the second parameter would be the request variable. So let's start with the function add item. We'll write func, the name of the function, that is add item, and we will pass the response writer, that would be the variable q, http dot response writer, and the next variable, that would be the pointer that would point to the http dot request. So we will declare with the variable r. Set up the REST API where we can send the JSON data in the request body. For that, we will declare a new variable in the body of this function, that would be add item. We will declare the variable new profile of type profile. Let's use new decoder, that would be JSON dot new decoder, and in the parameter it would take io.reader, that would be r.body, and in decode we will pass the variable where the JSON document should be decoded to, that would be the new profile. Now we'll send a JSON object in the function. That we'll write JSON dot new encoder, and inside we'll pass q dot encode, and we'll pass profiles in the encode. This takes the variable that satisfies the interface io.writer. The response writer here satisfies the io.writer interface. We can pass q and then encode. In encode, we can pass a value that can be converted to JSON. We can do this by using a struct, and we have used the struct profiles. We'll set up a content type header on the response. For that, we'll write the command w.header dot set, and in the set we'll pass the key and the value. The key will be the content type and the value will be the application/JSON. Because of content type, Postman will know the data is of JSON type. Here we'll be using Postman to send the request. So in the set, we will make the key the content type, and the value as application/JSON. Now let's create a slice and route to add items in slice. We'll create a slice, that would be variable profiles profile equal to square brackets profile curly braces. Now we can add the data to the slice. We can do that by using the append function, which is an inbuilt function. So we'll get back to the add item function and we'll use the append function here. That would be profiles equal to append, and we'll pass profiles and the new profile. Let's try and make some requests to our API. Here we will be using Postman to make these requests. So we'll start the Postman. So we'll create a new request and set the request as post, as we have declared the method as post, and the URL we will enter would be localhost colon the port number, that is 5000 slash profiles. Now click on the body and select row. Now here in this body we'll enter the structs in the JSON format. For that, first we'll define the curly braces, and our first struct was the property in the struct was department. We'll set the department as marketing, comma. The next was designation, colon. Designation would be research marketer, comma. And the next was I have to confirm that employee, and that is of the user type. So employee, and it has some fields inside it, so we'll declare those. That was first name, we'll make it as Adam, comma, last name, we'll make it as Adam Peter, and that would be in the inverted commas, comma, and we left the inverted comma, and the next thing was email. That would be Adam Peter 66 at the rate gmail.com. We forgot to build and run our code, so first we will return to Visual Studio Code and save the file and run the command go build. So it's showing an error, that is undefined http.listen and serve. Okay, so A will be kept up for the end. So we'll save the file and run the command again, go build. That .exe file, that is executable file, has been created. Now we will run this file. For that we will write the command period slash and the name of the exe file, that is rest underscore API underscore new and press enter. Now the file is running. We'll go back to Postman and click on the send button. Here you can see that we got the output, that is department, marketing designation, research marketer, and the details of the employee. So it has been posted. So our REST API is working and the connection has been connected with the localhost server 5000. Now we will be creating more functions so that we can perform CRUD operations. The CRUD operations are create, read, update, and delete. So we'll move back to the Visual Studio Code and create more functions. Create a route handler in the function main. That would be router dot handle function, and inside the circle brackets we'll write the path, that is profiles, and the name of the function we'll set it as get all profiles. And the method we would set it as get. So the H would be capital for the handle function and F would be capital. So in this function get all profiles, we would be fetching all the profiles we would be adding in a REST API, and we have set the method as get so that we can get all the profiles, we can fetch all the profiles. So now we will declare the function get all the profiles. So we'll write function name, that is get all profiles, and inside this is also a route handler function, so it would be taking two parameters. The first one would be the response writer, that would be represented by the variable q, and the second parameter would be http request variable, that would be the r pointer, that would be pointing to the http.request. So we will start with q variable that would represent http.response writer, comma r. Now the pointer that would point at http.request. Now inside the function we will send a JSON object in the function. For that we would write the command new encoder. For that we'll write JSON dot new encoder, and inside we would pass the q, that would be the response writer dot encode, and in code we can pass a value that can be converted to JSON, that would be profiles. Now we'll set up a content type header on the response. For that we would write the command w dot header, sorry, that would be q dot header because the variable is q here, dot set, and inside the set we'll pass the key and the value, that would be the content type and the application slash JSON. So we would write that the key would be content type and the value would be application slash JSON. Now we'll save the file and we will Enter the command Control plus C in the terminal to stop the execution. Now we'll save the file again and run the command go build, and now we will execute and run the file rest underscore api underscore new.exe. For that we'll write the command period slash the name of the executive file. Now we'll turn to Postman.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
We'll create a new request, and inside the new request we'll set the http.request as get only, and inside the URL we will copy the same URL and click on the send button. Here we got that the array is empty, so we will again go to the post http request. We have to run this request again because we have stopped the execution with the command Control plus C in the Visual Studio Code terminal. So we will click on the send button again, and we can see that the array has been passed into the request body, and we have seen that it has been successfully passed. Now we'll go to the get http request that would be following the function get all profiles. Now we'll click on the send button. We can see that it has fetched all the profiles that has been entered till now. We will post another profile, so we would be making some changes. That would be sales head, and the employee name would be Henriquez Pete, and head email would be henriquez99@gmail.com. And now we'll pass this request. You can see that it has been successfully entered. We have passed the request in the request body, and you can see the output. Now we'll go to the get http request and click on the send button. See that it has shown all the profiles we have entered till now. To see in the JSON format, we just have to change it to JSON. We can see that we have entered the profiles here. So now we will be creating another function that would be get the profile by a particular ID. Here we are getting all the profiles. Now we will be creating a function that would fetch us a single profile with a particular ID. For that, first we would be creating the route in the function main. Router dot handle function, and inside first we will pass the path that would be profiles, comma, the name of the function. We will set it as get profile. And we'll set the method here as get only because we are fetching the profiles. Now we will add ID in this that would be just beside the path. For that we will write slash, in the curly braces we would write the particular ID, the ID we would be searching to get the profile. Close it in inverted commas and put the function name also. Now we would be declaring the function. For that we'll write the command function and then the name of the function, that would be the get profile, that would be function, and inside we would pass the same response writer and the pointer to http.request, that would be the variable q, http.response writer, comma r, the pointer to http.request. In the function body, first we will get the ID of the post or the profile from the route parameter. For that, we will declare a variable, that would be variable ID parameter of the type string, that would be equal to mux dot vrs function, and we'll pass the pointer r in that would return us a map, and inside the square brackets we would make it the ID. The next thing we have to do is to convert the string to an integer. We can do this by using the function atoi, that is part of the string conversion package. So we have to import the string conversion package, that would be strconv. Now we'll get back to the function, that is get profile. Now we'll convert the string to integer. So it returns two values, one is the integer and another is error. We'll see id comma error. We'll define two variables and use string conversion and the function, that would be atoi, and pass the variable, that is id param, which we have to convert into integer. Now we'll check if error is not equal to null. If we do not have any error, so what we can do, because the function is returning two values, one is integer and another is error. If it's the error, then it won't be null, so we have to define that. Now we'll check the error. For that, we'll write the statement if error is not equal to null. So inside this, we would be writing a command q write header, so it would be representing a number that would be 400. If the error would not be nil, means that it has error, it would be showing the error. Now w.write inside we will pass the size of byte, and inside we would write id could not be converted to integer. Now we'll also do the error checking. But before that, we would write the statement return. So if there's a error, the next statements won't get executed after the error. and we have the W capital for the right. Okay, now we will be checking for the errors. If ID is greater than equal to length of profiles, here ID corresponds to the position in the slice. If it's greater than length, then it's invalid. Here we will write no post found and return so that code below doesn't get executed. So for that, we'll write the statement if id is greater than equal to length of profiles. Inside, we'll write q dot write header it would display the header as 404 and next statement we would write would be q dot write with a capital W and inside the round braces we'll pass the slice of byte and inside we'll write no profile found with specify ID and now let's get the post at index or profile at index. For that we'll write profile profiles ID and set it as key and value and the key would be content type and now we will set the encoder and pass the response writer q dot encode the variable name profiles profile json dot new encoder. Code it won't be in inverted commas. We'll get them cleared out. Now we'll save the file and write the command control plus C. Now we'll build the file. Now the executable file has been created. I will run the executable file. Now we'll move to Postman and now we'll enter all the profiles again. Then we'll fetch them. We have to enter them again because we have created and executed the exe file again. So we have one profile here. We'll click on the send button and we can see that it has been successfully passed. Now we'll get the second profile and we'll click on the send button we can see that we have passed two profiles. Now we will get on the get HTTP request. So if we click on the send button, it will get us both the profiles, and if we want to see them in the JSON format, we can see that we have got both profiles. Now we'll create another request that would be get and the same HTTP URL, and after profiles we have to make it slash and make it as ID 0 to get the ID 0, and we'll click on the send button. Here we can see that the first profile we have entered was marketing, about the marketer, research marketer, and we have got that. If we want to fetch this next profile, that would be the index 1. You click on the send button, we got that profile, that is sales head in the sales department. That was the second profile. So now we would move to another function that would be update. For that we would create another route, and that we would be creating in the function main only. So that we'll copy and paste it. We'll get the function name as update profile, and the method that would be put in capital letters. Now we'll declare the function. We'll copy the same function, that would be function get profile, and make some changes in that only. We'll paste the function. First we'll change the name of the function, that would be update profile, and we'll be passing the same parameters here. We would delete this part, and now we'll create a variable updated profile to hold the decoded data. We will pass the JSON document, that would be r.body, and in decode we will pass the address where we want to store the decoded data. So for that, first we will declare the variable, that would be update profile. It would be of the type profile. And we would be doing JSON dot new decoder, and inside we would be passing the IO dot writer, that would be r dot body dot decode, and here we will be passing the address where we want to store the decoded data, that would be ampersand update profiles. Now to update the profile value, we will do files id equal to updated profile, that is update profile. Now we'll send it to response, that would be, first we will set the header q.header dot set, and inside we would be passing the key and the value, that would be content type. and the value would be application/JSON. Now we would be send it to response. For that we'll write the command JSON dot new encoder, and inside we'll be passing the response writer, that is q dot encode. E would be capital of the encode, and inside we'll be passing the variable where we want to store the updated data. That is update profile. Now I'll save the file, and in the terminal we will write the command Ctrl+C to stop the execution. Now we'll build the file. Now the executable file has been created. Now we'll run the executable file and move to Postman. Here we will create a new request that would be of the type put, but before proceeding with that, we have to again enter the profiles. We have one profile already in the request body. So click on the send button. Here we can see that it has been passed successfully. Now we'll also run again the get all profiles. You can see that we have one profile and in the JSON format. Now we will come to the request that would be of the put type and copy the URL and paste it here, and it also has a parameter ID. So for that we'll write the ID as 0 because we only have one profile that is at the index of 0, and we'll copy the request body and click on body, click on raw of the type JSON and paste the profile here. Now we will update the department here and update it as content marketing. And click on the send button. Here we can see that the profile has been updated. The department has been updated to content marketing. So now we would be declaring another function that would be delete. For that we would be creating another route. For that we would move to the main.go file, and in the function main we'll create another route that would be the delete profile, and the function name we would keep it as delete profile only, and the method would be delete. Now we will declare the function delete profile. We will copy the function that would be update profile and paste it and make the changes in that only. First we would make the change in the name, that would be delete profile. Now we will send the response, and we don't have anything to send it in the response body, so we will delete this and we will send a 200 OK status, so we could confirm that the profile has been deleted. So for that we will write q dot write header, and it would show the status 200, and to delete that we will run a command that would be profiles equal to append, and inside the circle brackets we would write profiles set colon id comma profiles square brackets colon id plus 1 and period. So now we'll save the file and move to Postman and test the delete function. Now we'll save the file, and in the terminal we will enter the command Control plus C to stop the execution. Now we'll build the file again and run the freshly built executable file. Now we'll move to Postman, and first we will post the profiles as we have created the executable file fresh. Now we have to click on the send button. As we can see that it has been sent to the request body and we have get the response. Now we'll just run the get all profiles function. It is showing that it has got a profile in the JSON format. We will post another profile that would be of the department sales, and it would be sales head. So we have click on the send button and the profile has been posted. Now click on the get request and click on the send button. Here we can see that there are two profiles in the JSON format. Now we will create a HTTP request that would be of the type delete and copy the URL and paste it here, and it has the IDEs parameter. So we will delete the profile with ID 1 and click on the send. It is showing HTTP header 200 as OK, so it has deleted that profile. Move to get request and click on the send button. Here we can see that we have only one profile left. It has deleted the profile with the index 0. With that, we have come to the end of this session. I hope it was interesting and informative. If you liked it, please let us know in the comment section below. Also do subscribe to our channel and stay tuned for more from Simplilearn.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.